and today we are going to work on Kast, the programming language. Once again. All right. What we are going to work on is a question. Hello, Nigel. Any suggestions what I should work on? Should we try something specific today? Game? Start making a game with Kast. Alright. Not a bad idea, I guess. Fine, fine. Since Nigel says so. Oh, start playing a game? What game? What? No. We're not going to play a game. Which game? The only game that I'm going to play on stream is Factorio, I think. Unless you made a game? Oh, see, program lover. You was just watching the existentialization reading stream VOD? Yeah. It's probably better to just read the paper instead of watching the VOD. See, program lover. Hello, hello. Trying to make a game is not a bad idea, actually, right? I already have an example of the thing where we have something that's working in the browser, so we can make a game potentially that is going to work in the browser too, because that should not be that difficult, actually. Right? Should it? Browser. Yeah, we have like Canvas 2D rendering context and stuff here. I feel like I want this to be like on a separate repository though. Maybe let's do a new repository. Projects. GitHub create. All right. What kind of game would we make as the first game? What kind of game would we make? Like Asteroids or Pong or a Flappy Bird? dodge the square. All right. I mean, sure, why not? Let's call it dodging or something. We're going to yeah, spawn like new squares and we need to dodge. Pong. I don't know, Pong is like boring. Let's do something else where we need to where we need to dodge these squares, which are, I don't know, bouncing off the edges of the screen or something. I don't know, something. Let's just call it simple game cast. Cast game example. Let's just do this. Actually, let's not worry too much about it. Let's not do anything here. Okay, I'm going to just do yeah, like this. Let's add git ignore. Is that all? Maybe. Did I push everything that I had in my cast? Yes, everything is pushed. All right. Surflake just installs the things. I don't need Node.js. I'm going to target the browser, I guess, only. I'll keep it installed. It's okay. Maybe to test some simple things. All right, so now we should be able to create workspace KS file, and this is supposed to be a thing. Roots source main KS. That's all that I need actually. Source main KS. Okay. Print hello world. Right. So the way we are going to run this, let's create a just file maybe, and install just here. Hello, ICS boys. Good morning. All right, we're trying to start a new project here, which is a simple game in my programming language. Whether it's going to like require a lot of work on the on the language or not, we will see. We will see. Actually, let me open. Let's try the NeoVim today. Oh, can I set the GUI size in the NeoVide? NeoVide font size. There's NeoVide scale factor. Can you do this? I need to do Lua, right? I'm going to say Lua G. No, Lua Vim G NeoVide scale factor is 1, is 2. Oh, there we go. Nice. Projects, Kast lang, Kast game example. Right, nice. Hello, Julian K120. Looks like you haven't activated Linux. Yeah, I have not. I'm still broke because I'm working on my programming language instead of working on something that would bring me money. You know? So yes, so the way we are going to do this is just file. Just is created, right? Just file. Default hi. So we are going to say build, and this is going to do cast, compile, target.js, output target compiled mjs, source main ks, right? That's all that we need. That's all that we do. Just build. Okay. So now we are supposedly having the target compiled mjs. So this is our like compiled stuff. Yep. And well, I guess I want the index HTML here, right? So maybe I don't actually ignore this thing. Let's do index. Right, let's do index HTML here. HTML. Head. Body. Okay. We are going to load a script. Where do you load the scripts? In the head or in the body? I'm not sure. How does it work usually? In the body. Script. Source. Rel. Source is compiled mjs. Wait, can you do this without the things? The quotes? Really? npx create cast app when? Right. Let's see. So we do this. I guess I'm going to not ignore that, or I guess we're going to ignore target. Let's. You know what? Maybe we're going to ignore target compiled, and we're going to have target compiled like this. We're going to remove this, and we're going to remove that. I don't know how to reload this thing. So when we're compiling, we're going to compile to target compiled slash main mjs. That's just it, right? So we're going to ignore like that folder instead. So this is going to say compiled slash main mjs, right? So we do. Let's just actually. I mean, yeah, let's do just build, and then we do serve, and serve is going to be just build, followed by caddy, caddy, file server. This is the thing that I want, I guess. File server, we're going to listen, run like 8080, and the root is going to be target. That's all. Right, which means that we need to have the caddy installed. So let's install it here. Why is the font so big? Do you think I should make it smaller? Okay, maybe it is too big. Fine. Let's do 1.5, like this, maybe. Is this better? I feel like this was my default font, which is like a little bit too small. Let's do that. Maybe. Okay, just serve. So this is going to start this thing. It would be nice. I think Neovite does not allow me to click on the links though, right? Anyway, so we're going to just do localhost 8080 like this. All right, and I did not see the hello here, even although I printed the hello. Which is a little bit weird. Did I load the script? I did load the script. Wait, 304 means that it's cached, right? Or something not modified. I don't see this thing in the console. It's Axe that buys the version manager. Cannot run tasks in watch mode on Windows WSL. Never used it. Never used it. So what's the issue right now, right? We have the main. I am definitely printing this here, right? So is it that the oh wait, it's not. It didn't actually load it. Wait, so the file is not needed or something? It is not loaded into my sources. So is that not the correct way to do the HTML then? Well, first of all, it's a module, right? But I don't see any errors at all. Can I say type is module? $200 console debugger compiled main.js. Okay, so like, am I getting here? I am definitely getting here, right? Am I right now on this thing? Wait, no, I'm not. If this is loaded but it's not being evaluated, the only error that I have is the favicon. If I try to do node target compiled main, right, then hello world is printed, and this is supposed to be printed if it was working on the browser. So why is it not working? Well, let's do an inline script here. Script type is module, and we don't do any source here, right? Where I'm just going to say console log hello world. Like, this is supposed to work, right? I need to serve again. Wait, now I am actually getting this thing. I am on this breakpoint. Does it mean that it's going to be printed twice? So this is printed from main MJS. Wait. Hold on a second. This is so weird. I'm not getting this hello world, but I'm getting this hello world. What? Are you sure scripts allow self-hellos in text? Do you think this is the problem? I don't know. I don't know HTML. Yeah, I mean, maybe this is the issue. Yes, maybe this was the issue. Now I see both things. Okay, fine. Fine. So it was like, yeah, it's just weird, I guess. I have like this language server for like the stuff. Shouldn't it complain that does not allow this self-closing script tag? Anyway, so we can now like put some code here, right? So what do we want? We want to have a canvas. We want to load WebGL. We want to draw a triangle on the screen with WebGL, right? This is going to be a pretty long thing, I guess. But we should try by just getting the WebGL working. So let's say that we have the let's do this in line first, or let's start with actual just hello world, right? Sure. Just commit this. Now an error occurred. This is why I don't use neovide all the time. We're going to open VS Code here. It would be nice if things just worked when Vim is involved, but they just don't. Wait, I opened a file. Shit. Open folder. I hate it. Why? I want this to be as a tree view. Why is this not a tree view again? Where's the button? Did they move the button somewhere? View and sort. View is tree. There we go. Okay. Hello world. Okay, so now that this is working, we can start doing something. So we want to have a canvas on the thing, right? We're going to have a canvas. ID is like the canvas or something. Can this also not be self-closed? No idea. Remove the breakpoint. Can I have a style outside of the head and the body? Let's do this so that you can see it. Okay. Let's actually move this somewhere far away and work here. Okay, so I want to find the canvas, right? We need to create these APIs to work with JavaScript. There's multiple ways of doing this. We can... Well, I mean, one of the things that I can do, I guess, is I can have a little bit of a JavaScript runtime edit, or I can ignore that and try to do as much as possible in Kast directly, right? Just like I was doing for my browser example here. We are going to have the HTML canvas element as a new type. Okay, the server shut down for some reason. Header must provide a content length property. Weird. If I restart it though, then it's working. Isn't this supposed to be highlighted? Or is my language server like working, but also not really working? What if I reload the window here? Yeah, that's what I want. It's because it crashed. Not sure why it crashed either. Okay, anyway, so like the first thing that we need to do is we need to find the canvas element, right? Yeah. Here's the API that I had before. HTML canvas element, width, height, get context, HTML body, HTML document. Yeah, I was like creating this, but I wanted to be maybe existing in my thing directly. Also, let's make that sure that this is a web module. We're going to move it to its own file later, right? So we want to find the document. This is going to return us the HTML document element. I think everything should be opaque type though. Here, HTML body element, opaque type. So these are the types that we care about. No, I don't even care about the body here right now, right? We want to find the document first. So this is going to be just document. No native document. Why does it say no native document? That makes no... Oh, because this is run at compile time. It should not. Right. That's why. So we do something like this. Web.document. This is my document, right? And let's do dbg print. So this is supposed to be working. If I open the terminal, then we found the document. That's okay. Okay, then we want to have, let's say, implement HTML document element as module, so that we can figure out something, right? We want what do we want? What's the thing? Document get element by ID. That's what I want. Get element by ID. So this is going to be a function taking the document and ID, which is a string, and it should give me the this technically just gives us any HTML element, right? This gives us any HTML element. We don't have like a class system. Or anything. Okay, so there is going to be a native thing that we're going to call with document and ID. How will you do something similar to JavaScript inheritance? I think we will just have the casting, JavaScript cast. So we like treat type as a different type. Also, this over here is a little bit weird right now because I cannot like interpolate this yet. So we need to like create a function here which has like says takes document, which takes document and ID and returns document get element by ID, I guess. Okay. So in order to do this, we will say that a document is, we first find the document. And then we say canvas is document. So we want... one of the things that we can improve in the language right now, because I already changed the syntax, right? In order to not do the currying, this is the first thing. This is kind of like a method, right? Maybe like methods is what we want to implement real quick, right? We want to or like piping as the first argument instead of like the whole argument should be doable now, I think. So we can do like web HTML document element dot get element by ID. ID, right, where ID would be canvas for me right now. So this doesn't work right now because my pipe operator just thinks that this is a separate function and stuff. But we can make it to work just like the pipe operator in other languages, where document becomes the first argument here, right? In order to make this even less verbose, we kind of want just to do document.getElement by ID, right? So that this stuff is done automatically. I'm not sure if I can do this quickly, though. So maybe we will postpone that for later. Let's take a look if I can implement this fast. So we have the pipe operator and std syntax here, right? So the pipe is just being rewritten into this, where we call the function with arguments. But I guess we need to have a dedicated syntax then, where we pipe into a function and we apply it immediately, right? By the way, this has a priority of 14.5. But shouldn't the priority of this to kind of be... What should the priority of it be? What about the pipe left? In Gleam, what happens when you pipe left? The argument becomes like the last argument in the function call, if this already is a function call on the left side? Is that how they do it in Gleam? So let's say that we have the argument, and then we follow it by the function call, which is followed by the opening parentheses and closing parentheses, and like function args. Any? I guess I kind of want this to just be copy-pasted over here. I will just call this something else, farg. Let's just say this is args and this is the first arg or something. Okay, syntax. So we are going to implement syntax, you know, like first into f args. as something. This is supposed to work, right? So we say that first is first, f is f, or I mean, yeah, I guess we just do f first and args just like this, right? Okay. And now this is showing me the error because browser canvas rendering context. So this is our existing browser example, which doesn't work anymore. Also, by the way, this is this error should be reported in other places, but because we're using the pipe operator here, because this is a function that we call, this is going to be the first argument, but we instead yeah, so we're here doing it with currying, but now we're not going to do it with currying, right? So we just say context like this, right? Context like this. Move to context, line to context. Okay. So something like this. Okay, let's just try the browser again. Let's do 8081 localhost 8081. So this still works, right? We can draw a house, and this is a different pipe operator. Let's commit that. Okay. Pipe operator makes arg first arg, right? Something like that. Sure, the proper methods would be nicer, but let's just do this for now. So this is just how we write this code now. Right, there you go. So this is supposed to work. So this canvas returns me now the HTML element. We want to cast this to HTML canvas element. I guess I think what we're going to do. So this is over here is dedicated to web APIs. And I think we're going to have something like generic JavaScript APIs, and we're going to have something like unsafe cast. Basically. Yeah, just unsafe cast is what I want here. So this is going to be a function, you know, like tu, where we have value of type t, and this returns value of type u, right? Just transmuting basically. So we are going to use this if we are certain that the thing is correct. What does the module go inside the parentheses? Yeah, I was thinking that maybe I do this, but the idea that why I did this originally is because I like when you write a library, this is supposed to go into a file, so you don't want the to surround the entire file in parentheses. But maybe this could be a separate syntax which is similar, I guess. Just goes on the outside. I don't know. Nothing on the syntax is final, so this probably will change. So this, I cannot do the unsafe casting right now in the language itself. We could implement it, but we instead go through JavaScript, I guess. Native. So we're going to have a function that takes X and returns X, I guess. And then we just call this function using A. Yeah, sure. Okay, so we do this, and then we do JS unsafe cast. So this is going to be HTML canvas element is the idea, right? So, and then we like just do dbg print canvas to make sure that it was actually found. I guess I kind of want here to watch all of my files and like rebuild. Maybe. Yeah, there you go. I found the canvas. Can I just watch in the background maybe and build? Is there something that is already available for me to do this? In Linux maybe? Where I just watch for anything to change in the in a specific folder. So if something changes in the source folder, then I want to just call the compiler. So that I will always see the live thing. Is that possible? How to watch for any changes in folder and invoke command Linux. I notify. Debounced version, don't spam your command. Sure. Let's try that. Just let's do it as a separate command. Build a watch. So we're going to do this. Path to folder is going to be source, and we're going to do just build here. Wait, I cannot do these things here. Recipe line has extra leading white space. Just while loop. Multi-line constructs. To work around this, you can write conditionals on one line, escape the line with hashes, or add... Yeah, because... Okay, I see. Because it is treating every command as a separate thing. Just build a watch. No. We can also... It also says that I can just do this. USR bin and bash. Okay, I notify wait. I notify wait. I notify tools. Just going to install this here. Right, just build watch. And in the other one, we're going to do the serving. Right? Yeah. Okay, so here, let's just test this real quick. Let's test this real quick. Does Nix not have deps versus dev deps like npm or cargo? It does, but I'm making a dev shell, so everything is a dev dependency. But when you make a package, well, I mean, when you make a package, you create the package dependencies for like how to build the dependency, right? Canvas ID. Let's print hello world 2. So I'm just going to save this file and go back to the browser and print hello world 2 because it was already recompiled. So that's nice, right? I just don't even need to invoke the compiler. We see all of the warnings here potentially. Okay. All right, so now we have the canvas, and we're going to get the WebGL context, right? Yes. So the canvas element, we're going to implement HTML canvas element as module. So for the canvas element, we need to get context. Canvas HTML canvas element, and let's go back to the documentation. HTML canvas element get context, right? Context type. There is also context attributes, but we just don't care about those yet. Context type is a string. So this will return once again. No, this is going to return. I mean, I guess in this case, let's just do. We want to have like something, like some JavaScript thing, right? Unknown. We can say that any is opaque type. There we go. That's what we can, and we can return any here, I guess. Because it's not necessarily in a WebGL context. Okay. So something like this. So we say that let context be canvas web HTML canvas element get context WebGL context. So this is any, but we are getting the WebGL rendering context here, right? So we're going to cast this to web. It's called WebGL rendering context, right? So we're going to once again do the unsafe cast here. And then we are going to have a WebGL rendering context. And we're going to have something here. So for the first thing that we want is we want to basically change the white color to something else. We're going to use the clear command. WebGL rendering context. WebGL rendering context, right? We're going to start with the simple stuff, which is called clear. Clear. There you go. Clear. So we have the clear method. And it has a mask as the thing. I kind of want like the GL. I'm not even sure if I want the API like this. I think it would be really nice if we had like the GL in its own thing. Let's have like ideally, I actually use the modules here. We have the JavaScript, we have like the generic web stuff, which is not going to be a lot. Can I call this lib? Maybe. So we're going to like put this somewhere else. This is not specific to this game going to be, right? Yeah, so like JavaScript is like this thing. A web is like this thing, and yeah, so I want to say I guess for now I'm just going to include, because my import system is kind of broken, so we're going to just include lib ks like this. Which is going to say that JS is include JS, and web is include web. This is KS, right? And GL is include GL. Okay. So WebGL rendering context. I feel like maybe I don't even do this here. Maybe I don't even do this here. Right? So we just have this type, right? But GL, so this is supposed to be like a wrapper over the WebGL rendering context is the idea here. So I want to have, yeah, so like GL is itself a thing, right? And we will have the context here. Which is a type which contains the WebGL, which is WebGL rendering context, right? Like that. New type. So that's what we do. And then we do implement context as module 2 here. I feel like this should just be impl context, just like in Rust. Right? So over here now, because like later we'll have not only the WebGL backend, but also the native backend is the idea here. So this is the wrapper, and then we'll have the clear method, which has like, let's call it self, which is context, and this returns unit. So we will just say over here that this is going to call native context into context clear bits, All right, so we will also have the bits. Yeah. So this must be. Do you not need parentheses in case you do like in JavaScript? Let me try this. If we do JavaScript and I do like, so if I do a function x into x, this is a function, right? But if I do this, this doesn't work, right? So like for this, I need to have parentheses so that I can call this function with an object which has x, like something, right? Yeah, I need parentheses there. Okay, so we do parentheses, context, and bits. And we do this. And we call that with context being self WebGL. And bits is just these bits. So bits is what? This is supposed to take any, like... Is there types in the web, in like over here in LDN documentation? This is a GL bit field, right? So we want this to be GL bit field, right? But GL bit field unsigned long. What is an unsigned long even? Let's like I want this to be like inside of a types, maybe. 64 bits on everything except Windows. It's actually 32-bit on Windows, really? Well, I mean, this is WebIDL. It doesn't really matter. Kind of. Why is the WebIDL even like doing this? Though, because this is a specification for the JavaScript API, right? JavaScript doesn't have these types. I'm not sure how this is written. Like, it's not C, right? Or is WebIDL supposed to be something that's implementable outside of the browsers too? I don't know how this works. Anyway, we're going to just use int32 for now here. We're going to... yeah. Or, I mean, let's follow this documentation and just do all of these types here directly. How about I do unsigned long. We're just going to go through this in direction. And then later we will maybe do the proper types. Because I just don't have anything that I need 32 in the language currently. A GL boolean, by the way, is a boolean. Do you actually use a boolean on the JavaScript backend? I'm not sure. When you work in JavaScript, do you supply like numbers or actually booleans? Unsigned long. Unsigned long corresponds to 32-bit unsigned integers. Yeah, like I'm not sure what this typing has to do if JavaScript does not have it. Right? JavaScript does not have 64-bit unsigned integers. Hello CD4, no? It's probably WASM. But WASM doesn't expose these APIs, at least not yet directly, right? JavaScript cannot talk to the WebGL, for example, or like any of the APIs. It needs to go through JavaScript currently. Just saying that the implementation has to support the values. Yeah, maybe. I don't know. Like, maybe there's some answer to this question in the actual specification. What that means. So this is supposed to be an unsigned integer. Unsigned integer is also just an integer for me currently. Okay, Boolean. Let's just do all of these types here. GL byte, byte. I don't have bytes. So this is supposed to be a uint 8, right? Uint 8 is supposed to be uint 32 for now. That's okay. We're going to lie. By the way, this is signed. That's different from the U byte, right? But long is still 32. Yeah. Long is that. So the specification says, by the way, that long is not 64-bit on everything except Windows, because this is different from the long in the in C, right? So in C this is different. So this is always a 32-bit. Yeah, it's not like really relevant. I'm just thinking that I'm going to write this immediately so that I use this in the future. It's not really like relevant. Also, technically, I think in the future I'm going to generate these APIs by parsing the WebIDLs just like the Rust does for its libraries. Like I don't want to write this by hand actually, maybe. Wait, by the way, we cannot do an int64. Int64 is a thing which is represented as big integers right now. So I'm going to do this as int32 too, currently. Because we're not supposed to use the big integers when working with WebGL anyway. Everything is an int32 basically. There you go. Octet? What the hell is octet? Eight-bit unsigned. So byte is assigned, but octet is unsigned. I have a programming exam. Buff me with language engineer stats. Yeah, good luck. Good luck with your exam. Pretty sure you should be able to do it, right? You're making your own programming language. Why would you, like, ever fail your exam? You definitely know how to program, right? Okay, you know what? Byte. I want to like keep the names close actually to the original thing. So this is going to be octet, and this one is going to be byte, and this one is going to be short, and this one is going to be u short. Whatever. There's unrestricted float. Is it different from float? Unrestricted float is a floating point number that includes this thing. So this one does not include the finite, non-finite. Does not include the infinite numbers and the nuns, probably. And if it's restricted. Okay, we only have the float 64 for now, so whatever. I'm not making a programming language, I'm writing a game engine. Oh, well, same thing basically. Apparently, WebIDL has internal functions to cast clamp the values so they are compatible with native code, which expects more strict typing. Yeah, makes sense, I guess. Okay, so here we have the types, now we have the clear. This takes the bit field, and we also need the constants, right? We also need the constants. I kind of want to let's just include constants like this, and this is going to be include types. Like, yeah, sure. We're not going to make this a module. We're going to have the folder GL. This is the GL itself. And then we will have types. Just like that. Top level, sure. So this is going to be GL then. And then we have the constant. Okay. No errors so far, right? So the constants that we need is because when we clear in WebGL, we need to specify the things, right? The mask, the color buffer bit, the depth buffer bit, and stencil buffer bit. Although, hold on. So these things are technically constants, right? But we also have these things available through the things. But these constants are actually specified in the WebIDL. So we're going to keep them as actual constants in the code and not as references to these things, I guess, right? So color, depth, and stencil. The color is the important one that we care about currently. So how do I like figure this out? These constants, is this in the specification of what the constants actually are? This is where we actually want to parse it, right? If we want to keep it as constant. Is there some, like, maybe we can actually... I don't know. Let's not worry about it for now. We're going to do something small. There's not going to be that many constants, right? But where do I get the values of the constants? Control F for them. Is this like the full specification that I'm in right now? Color, buffer, bit. Yeah, I guess. There we go. So like, yeah, we have this code. Okay, I see one thing though that I need to do for this to work properly. So, yeah, we just want to like rewrite it like this. You know, we have const. The next thing is the actual type, which goes here, right? So we want something like that. And obviously the 0x is the syntax that doesn't work right now. So let's do this real quick. This syntax should be supported in the language, right? Let's do that. So this means that I need to go to the, not the lexer. I mean, the lexer also, right? The lexer does not even do this at all currently. Read number. So read number is just a thing. To should be to do. Where? Oh, over here in this thing. To do. Sure, thanks. So read number is just allowing us to read the integers and dots. I don't even do the like the E format for the floating point numbers. This is very simple. So what we want is to do the hexes. For the hexes, is there a way to do hex like literals for floating point numbers? I guess you use this only for the integers though, right? Anyway, is there yeah, I can pick two actually. So we will do a dedicated thing then. Read hex is going to be its own thing. So C is reader, pick reader. So this must be a digit, right? And then like X is reader pick 2. And then we want this one to be specifically the X, so 0x. Oh wait, hold on. This one should be 0 always, right? It's not even this. So we want the 0, and then we want it to be followed by X. Right. So if we do this, then we are going to we need to advance the reader twice. And then we just read while it is a digit. That's all that I care about, right? Hex for floats works the same. You can have a decimal point, a hexadecimal. I just never used them. Do you ever use it? I'm just going to keep it raw here. I guess. So we try to read that before reading the number. Read hex. Wait, is this even correct? Why is it doing 67? Oh, 67 is just a part of this? Well, that's a coincidence. Okay, just part of my invocation ID here. Yeah, I'm just printing 1. And then we'll do 2. Is this right? 0x123 is 291, right? So like I'm just doing the int parse, I guess, and that is already supporting, so I don't even need to do anything. I just needed the token to be parsed properly. So the OCaml int from string already handling the 0x's, it seems. Okay. Hex literals. Shouldn't read hex and read number, share most of their code. I don't know. Maybe I did not allow the dot here. Also, this is only reading the token, right? It is not reading the value, because I just have the token as a number, even if it's like an int 64, int 32, we don't care about this. Then this number is actually going to be parsed later, depending on the type, because the way I want it to work is that your number literal should work for your custom types, like big integers also automatically. So this over here is just the job of the lexer. And actually parsing the literal is happening later after the type inference has done its job. Any Kast processes that are using 10 gigs of RAM? No? Okay, good. Actually, I should just sort by memory. There we go. Actually, there is 5 gigs of RAM. That's okay. Okay, there we go. So this is now parsed. We can format the code. We can start serving again. Wait, what? Oh, wait, hold on. Just build watch is not doing the build immediately. By the way. Right? I want to start with a build. So I notify wait is waiting for something to happen. But if nothing happens, I still should build once. At least, right? But this is done through... Yeah, but it's going to still continue doing something. Wait, actually, no. This was built properly. Right? But just serve... And just serve is actually working. Okay, nice, good. Okay. Okay. We have the constants. We will move more constants here. Now we can just do that. I don't have a syntax for the bit operations, but we don't care about that much. And we don't need it, because all I do is I do context GL GL context clear GL color buffer bit, right? That's what we want. Wait, WebGL recursive, what? Hold on. Context has the type this. WebGL rendering context. Oh, wait, because this is a WebGL rendering context, right? I don't want the WebGL rendering context. We need to first convert this to the actual GL, right? Something like GL context init, maybe, is what we want to have. So we have init, which is going to have the WebGL, which is WebGL rendering context, and this should return the actual context now. So this is just going to return like WebGL. We just stored this here. Maybe we will have some other state here later. I don't know. Although I want this to be a thin wrapper about around WebGL, and then maybe an extra wrapper on top of it. We'll see. I don't know yet. Main. Yeah, so this is not a WebGL rendering context. This is a GL context. Right? Right. And now we don't have any errors. Now we go here. Okay. But I think we are clearing with color 0. So in order to tell OpenGL what to clear with, we need to tell it the clear color. So the next thing is the clear color. Clear color is the thing which has red, green, and blue, which takes the clamp Fs. So we want to do context, GL context, clear color. Let's do I like 08, 08, 1.0, 1.0. Red. So what do we do here? We just forward this to the JavaScript. Context, RGBA, clear color, RGBA. Context is this, RGBA. Okay, there we go. There you go. The color is on the screen, so we are almost there with the game, right? Okay. The next step is to draw a triangle. That is going to be a little bit more involved. So we need to do multiple things. First, we need to compile a shader, right? But let's commit this. GL clear is done. Okay, so what we want is to create a shader. So we have a thing which is called yeah, I don't know, maybe we do this here. Shader is this thing, new type. Handle, let's have this to be opaque. So what we want is we want our context to be able to create a shader. So the process of doing the shaders in WebGL and in OpenGL in general is weird. You create it first, then you attach the source to it, then you compile it, and then you check for the compilation errors, and then like that's how you get the actual shader. And then you link multiple shaders together into a program because you have a vertex and a fragment shader. And that program is something that can be used for rendering now. So we want to start by creating a shader. Right? I'm just wondering what is the API that I want to have here. Something more high level or low level, or just like the OpenGL? Maybe let's keep it low level, just the OpenGL for now. Right? Yeah, right. So let's just have these functions here. Create shader. Self context. So we have a shader type. GL vertex shader or GL fragment shader. Which is of type GL enum, I believe. So this should return shader. Create shader. T. So this is going to be the handle. And we return the handle. Doesn't mean that I just do this as a new type then. Like, why am I making a wrapper with an extra field here? If this is going to be a thin wrapper, then let's make it as thin as possible. I still want it to be like kind of maybe like a different type. Right, so we're just going to say WebGL JS unsafe cast here from one thing to the other. And this is just going to be self then. And I guess we can just call all of the selves to be context, and then we just do that. That's okay. So this is just going to be opaque type actually, and we just return that directly there, right? Although this thing can return null is the problem. So do I want to, once we are doing this, while we're doing this, to check for nulls here, right? So this should technically return not necessarily a shader, but an optional shader, right? So either some or none. Okay. Yes. Yes. So if I have a native function, this is just going to work. This is going to return something. Maybe I just pipe this into JavaScript. JavaScript optional. JavaScript like check null. Check null. So we will have a function check null, which is like t. So this is basically like takes the any type, right? But it will return option T, I guess. So we're supposed to do this after calling like the thing. Yeah, sure. So it's kind of like also doing the unsafe casting also. All right, fine. So this is just going to be native x. So we return x is null. Then I want to create the option null, which by the way means that like I don't want to hard code the way I'm representing the variant types in my language. But at the same time, well, I mean, I cannot even do that. I need to have a function is null. Then, right? Yeah, I want to have the function is null. Any, and this should return boolean. So check null would be something like if A is null, then we're going to return none. Otherwise, we'll return a unsafe cast, I guess. So this is going to be native x x is equal to null. Do I need parentheses here in JavaScript? I'll give it parentheses. So create shader, since this is supposed to do the option. We do JS check null. And I just need to do null semicolon. Okay, and this should work. Okay, so after we create a shader, we are going to... yeah, and also I need these two constants. Right? Wait, can I just copy all of this? Can I just copy all of this? All of these constants? The constants are all in the beginning here, right? Can I just copy this entire thing? And move this into my constants. Right, we just need to change the syntax here, which is very easy. All of these are going to be hashtags. Like that. And we'll do const. No. Const space. Match the case to. Is there a faster way to select all of this? I mean, I can replace with regexes, I guess, instead of doing this. But yeah, we're going to say const. So this is the type. Then we have the type like this, and this is equal. And that is already working. Nice. Wait, what? That's a small file now, so it's not. Fine. Oh, wait, hold on. D. Shit. I did the hex literals incorrectly. We need to, like... I did not... It so happened that this constant did not have any, like, letters in them. Read hex. This should be like char is hex digit, right? Is there no is hex digit? Okay, let's do x hex digit. Like that. Is hex digit. So 0 to 9 is true. A to A, B, C, D, E, F, right? F is true. Let's do capital ones too. Otherwise false. Okay. This should be good. Right? X digits include letters. Lol. Other than that, I think this should all be parsed properly. Seems like some of the constants are like commented out. Browser default WebGL. Okay, before we try to make a simple game, we need to... So we have, like, initialized WebGL context, right? GL clear is there. Now we're trying to GL, like, shaders. Ryzen 5 old school. Yeah, I should update, right? I'm just too lazy, you know. If I buy a new CPU, then I need to like get into my my thing, and then like the cable management is like ugly there. I just don't want to open it at all unless I have to. Okay, there we go. So these are proper constants now. And this is formatted. Nice. There's like 3900 or something. I thought you had an actually like powerful modern one. I mean, 3600 that I have, it was also not like the best one when I got it. But I was broke. Make sure that this is reloaded. Okay. All right, I have potentially created a shader. Maybe I should... maybe we can try, like, step by step, right? We want to create the shader. Context, GL context, create shader, GL vertex shader. We want to create two shaders to do stuff. We want to have a vertex one, and we want to have the fragment shader, right? So let's do console log, no, not console log, dbg print vertex shader fragment shader. Oh wait, this must be like unwrapped, right? Because this is an optional shader. So this should also be option unwrap. Option unwrap. Okay, let's take a look here in the console. Pattern match non-exhaustive at option. Wait, what? That makes no sense. Unmatched value WebGL shader. Okay, create shader is not correct. JS check null is not correct. Maybe. Oh yes, because this should be like some a. Yeah, there we go. Yeah, because unsafe cast was not type checked properly. This is the issue. Okay, there we go. We have an object. Vertex shader is a shader. Fragment shader is a shader, but these are empty. Doesn't Rust throw errors like in Rust? Yeah, it's panicking. Just like in Rust. Okay, now that we have these shaders, the next step for the shaders is... So we will need to compile the shaders. Before we compile them, though, we need to say shader source or something. Shader source. Yeah, we need to do shader source. So shader source just has the shader. So this is like I mean, this is still a method on the WebGL rendering context. So we still need a context here. Shader, and source is just this string. So we in WebGL we just do this string, right? Because in C we don't. You hate Rust, by the way? Can you explain a bit more why you're using WebGL now? Because my language is transpiled to JavaScript at the moment. I want, like, my goal for using the language eventually is to use it for making games. JavaScript is just the easiest compilation target. Web is very good to show off your game to other people when it's small, right? Especially when you're participating in a game jam. So WebGL is the way to do a game in a web browser. The other option that it was like created recently is the web GPU, but I'm not even sure if this is usable at this point, right now. How many like devices actually support the web GPU? Like, I feel like the WebGL is the only thing that I should be doing. The only thing that might change is I'm using WebGL rendering context, not WebGL 2 rendering context. So this is like very old WebGL, but that's what my current game is like. I'm used to this API, so I kind of like know it, I guess. Why do you not use my steely filing concept? And if I source as template literal string, and you simply compile that then with many compilers, huh? Is there a link to your language? Steely filing. This one, a single architecture to rule them all. Heck, ECMAScript runtime. A single architecture to rule them all. And ECMAScript runtime. A single architecture to rule them all. Are you saying that ECMAScript runtime is the runtime to rule them all? Alright, there is too much stuff to read here, but you're making something, I guess. 4 years ago. The amount of source code, especially this one, which only has the README. Is there even anything here? Or is all of the source code just commented out? Domain not configured. Oh, this is a different one. Okay. That's JavaScript gem. I'm not sure what this is. A JavaScript gem. Anyway, let me go back to my stuff. Shader source. Just returns unit. Source is a string. Context shader source. Context shader source. Shader source. Context shader source. Dun, 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 dun. Okay. All right, we need to attach the shader source and then compile it and then check for errors. Compile shader. Okay. Compile shader. Are we going to do shaders in Kast? Not yet. To do shaders in Kast, I need a transpiler to GLSL, which is also planned, but it's not here yet, right? So, no. Even this, what I'm writing right now, this thing over here should be generated, but that needs more work, I guess. I'm just trying to do something simple for now with what I already have. Shader source, compile shader. And then after we compile the shader, we need to check for the errors, right? So get shader info log, or I guess get shader parameter, compile status. That's what we want. Get shader parameter. So this actually returns based on whether we are checking for the boolean or an enum. So because we don't do the overloading, we are going to have get shader parameter boolean, which is going to be context. Let's try to ask LLM to generate other functions. Actually, I don't know. If I give it this source code, that it might be able to generate the thing. I don't know. It's like I'm not going to write that many functions, so I'm okay with doing this by hand. Shader and the parameter p name is GL enum. And then we expect the boolean here as a result. So this should return GL boolean. Get shader parameter. Shader p name. Okay. So Frank, you're doing the JavaScript to native compiler. Is that what you're doing? There is too many messages. The ADA so internally already. Yeah, I understand. In the JIT. Not everything can be jitted though, maybe, or it can everything be jitted. I have no idea actually. There's only tooling around that and integration. I see. Yeah, I was like looking the other day if I can actually just convert my JavaScript to the native binary directly, so that we don't need to have the dependency on the node. So we can have a proper compiler basically from Kast to native code by compiling JavaScript to native code, right? Yeah. Okay, so we will need to get share parameter bool. We will need to check the compilation status, and then to get the actual error, we will need to have a gate shader info log. So we will need also get shader info log, which returns string context shader and returns a string, right? Yeah. Context shader get shader info log shader. Okay, so this is supposed to work. Let's see. I'm going to try and compile something that actually doesn't compile first, right? So here's our vertex shader. We create the vertex shader, then we say context shader source vertex shader vertex shader source. Okay, const vertex shader source is I don't have like includes this. Actually, I mean, yeah, we do want to include it, right? I don't have an include string yet. But I can, I guess. Include string, or I guess we don't do include. This is a constant. We can just do stdfs read file. I think, and we give it. So we read the file like relative to this file. Oh, we want std path dir name of the file, and then we add slash vertex dot glsl. Yeah, how about that? This does not even report the problems. This is supposed to report the problems. It is. Oh, wait. Yeah, this is actually giving me the exception. So, yeah, the LSP is crashing when I'm doing this. Unless I actually have the file. Vertex glsl. Here we go. So this is actually compiled now properly. Okay. We will do the same for the fragment shader source. Let's create fragment glsl. Fragment glsl. But first we just do this. So we do shader source, then we do context compile shader, vertex shader. After we compile it, we need to check its status. So we say context get shader parameter boolean. The parameter is compile status, right? So this is going to be a compile status. We say that if not, so compile status is a boolean, right? Right. So we say that if not compile status, then we need to like panic. The shader has not compiled, and the error message here is going to be the error message which we get from the actual like shader here. So we say context context get shader infolog vertex shader. Do you got plans for multipath compilation or pass multipath compilation? No, I specifically want my compiler to be not having any passes. I do everything in a single pass because everything can because we can evaluate some code while compilation. We can evaluate while parsing. That's how macros are done, right? And like we can do the inference while we are still like doing other things. Like all of the things, the inference, evaluation, compilation, all of these things are happening at the same time. I specifically want to not do multipass compilation. It's more nested than sequential. It's not nested, it's async. So like all of the things are like for example over here, right? I say constant vertex shader source, right? And this is basically evaluating this thing at compile time. So in order to evaluate this at compile time, I need the standard library to be compiled, but I don't need the entire source to be compiled. So it does not need to be compiled right now, though. It just needs to be compiled when I need the value of this constant. So this over here kind of like spawns this evaluation process in the background, I guess. 1 second. All right, I'm also going to go and do a lunch break in a minute. But yeah. So you compile on start, or you pre-compile once. There is no pre-compilation, or like there is just compilation process. But the compilation can be suspended to do evaluation, to do like things. All of the things are just async. So sometimes we pause what we're doing and we do something else. Is the how my language works. All right, so when we panic here, I want to get the shader info log. Right, so this is going to give me the string. So this is the log. Right, log is a string. So we just panic with the log. We can also... Well, let's just do this right now, right? So if I just... something is not compiling, actually. I need to fix my error messages. That would be really nice. Because they are reporting the error messages in the inside of the macros. Instead of this. Hold on, where the issue is. Oh, get shader parameter boolean. This over here needs to have the vertex shader too, as the argument, right? Okay. No recursive imports is probably fine. Okay. So this, let's take a look here. There you go. We have a panic and we have a syntax error at line 1, column 1, syntax error, because my shader source is actually empty, right? Okay, we can also say that not just log, we can say, you know, shader compilation failed log, like this. Right, so it's going to say shader compilation failed, syntax error at line 1.1. Then now, if we do the actual vertex shader, so the vertex shader, they look like this. Where you have like main, and you have like GL position is something. We're going to have attribute position like this, and I will do a 2D thing for now. And we will have vec4 position 0, 1, like this. So we are going to have our vertices are going to have every vertex is going to supply us with a 2D vector, which is the position, and we're going to put this position on the screen. Okay, so this actually compiled successfully. If I say something like position 2 here, though, then it says that, yeah, position 2 is undeclared identifier, so yeah. There you go. This is our vertex shader, the fragment shader. Let's also do the simple one. We're going to just say that everything GL frag color. So what color we're going to write into the thing? Gonna do D2 gem and cast. That's the like that would be nice, right? If I can do this. Which I maybe actually can already. So let's just do the like some red color, sure, red color, like that. Okay. So let's actually wrap this into the thing. Can't wait to play new Command where we play the trip. Oh yeah, by the way, we will need to have like the lists probably at some point to supply the vertex data, and I don't have lists yet in the language. Okay, let's wrap this into a function, you know. you know, like compile shader. This is going to have the shader type and source, and this is going to do all of these things, right? But it's not a vertex shader. This is just going to be a shader. The type is this shader type, and we just return this thing in the end, shader, right? So this is a function which source, yes, source should be source here, right? So this is a function that which takes, this is a GL enum, I guess, and this is a shader source, and this returns the shader. So we say that vertex shader is compile shader GL vertex shader vertex shader source, and we will do the same with the fragment shader. Fragment shader source. Okay, which means that they are both going to be compiled now. Seems like they are. Let's just try to make a bug over here, vec45. Yep. So this actually is trying to be compiled. Crazy, you just did all of this to avoid writing JavaScript. Yeah. So now that we have this program and this program, we need to do the we need to link it into a program. So vertex plus fragment shader combined is going to be a program. Then we are going to use that program to draw, which will means that we will need to like vertex buffers first also, and then we actually like draw triangle. That's how going to be our goal. But first, I'm going to go and take a lunch break. All right, I'm back. Okay, so we are in this step where we need to link the program. So we need to combine these two things into a single program. So the next functions that we need is we need to create program. This will return program. Program is going to be another opaque type. Pretty sure that just is it. By the way, can the other functions that I have done so far fail potentially, like create a shader? This can return null if an error occurs when creating a shader because type was invalid value. Yeah. Let's make sure that that is actually like handled. So create shader should return. Well, I mean, I already did it, right? Check for null. Okay. So create program is also going to be an optional program. Hello, Penguin operator. Maybe I should put in my title that I'm doing WebGL with my own language. Yeah, so we do this, and then we do JS check null, right? So we create the program. After we create the program, the important things are link program, use program, validate. Wait, validate program? I never used this thing. Validates, it checks that if it is successfully linked and it can be used in the current WebGL state. Interesting. I never used this thing. But we kind of like need these things, but for the programs. So instead of compile shader, it's going to be a link, and instead of a shader, all of these are going to be program. So we're going to have a program info log. Program, and all of these shaders are going to be programs, right? Let's see what we have here. Hello, Kyle Kinsella 123. I'm very interested. Have started to do my own compiler and interpreter. Nice, nice. Is there any info about your stuff, or is it just starting? Okay, we create a program, link program, get program parameter bool. So we are going to get the parameter whether the link status was success or not, similar to compilation status of the shaders. And program info log is to retrieve the error message. Okay. And another thing is attach shader. Attach shader is what we need to do also. So we need to do attach shader. This thing has program and shader. Program shader. like that. Okay, I think that's all that I need to do to link the program. So we go back to main. After we have the vertex and shader thing, we say that program is context, GL context, create program. Option unwrap. By the way, GL context, we have this all the time. How about I just say context, or let's just say GL, like GL. Yeah, sure. How about that? I can just say that GL is GL context. So we have the program, then we say context attach shader, program vertex shader. We will also need to attach the fragment shader. After that, we need to link the program. After that, we need to figure out if it was compiled or not, right? So link status is context get program parameter boolean program GL link status. So if not link status, then it means that we failed. So we're going to say that the error is something similar, but we get program info log for the program. So this is program link failed log. Let's print the program in the end. And see. So like this actually should be successful. Yeah, we have the WebGL program. How do I make sure that my program is not successful? I think if this is called main2 and not main, the compilation is still going to succeed, but the linking is going to say that the main is not defined. No, it still is missing main in the shader compilation. Maybe if I try to have a function that is not defined, because you can like combine your vertex shader from multiple like programs, right? Like just like in C, you can define some function f, and over here I'm going to call the function f, for example, and this is going to this is undefined function f using the following call chain main. Wait, what? What's an example of a linking failure? What's example of a WebGL link program link failure? Oh, wrong type. Yeah, because we have varying, right? Because we need to like because the vertex shader can give me some like thing, right? I just say something like vpos is apos, and in the fragment shader we can say varying back to vpos, so we can like change the color based on the position here, kind of like this, I guess, right? So this is still supposed to work. No precision specified. Yeah, that's because in the WebGL you need to specify the precisions. Precision, precision medium p float. Do I need to do it like for the things separately? Like for the vertex and the fragment shader? Right, so this actually was compiled successfully. Wait, did I remove the clear? Why is this white now? No, the clear is still supposed to happen. Hello? Oh, wait. If I do Control-Shift-R, then it works. Okay. Okay, so... yeah, so what happens if in my vertex and fragment shader I use different precisions? High precision. This still kind of works. But if we change this type... no, not this type. If we change this type... then we're going to have the actual link error, right? Because varying vpos is not linkable between the attached shaders. Nice. Okay. But we're going to go back to the actual program that works. So the next step, to actually have the triangle on the screen, we need to do the draw call. WebGL, let's see. So in order to do the draw call, we need to say draw. There is two things, draw arrays and draw elements. Draw arrays is just the only difference is that one of them is using the indices, I thought, right? Renders primitives from array data. And this one also renders primitives from array data. This one has mode, first, and count, and this one is having mode, count, type, and offset. Yeah, because we have the element array buffer, which is giving us the indexes into the other buffers. Makes sense. We're going to use the draw arrays here because it's simpler. So what we need is we need to have our vertex data in the vertex buffers, and then we can basically first and count. This gives us so we can draw like the vertices in this sub array basically. So we need to have an array with the data, and then we can draw any sub array easily. And the draw elements is allowing us to have another array which is indexing into the array with the actual vertex data. So this one is simpler. Let's just do this. We can draw triangles, points, and lines. Okay. We also need to use the program before we do this. Right, let's do the use program first. GL program, use program. let's have this function also immediately draw arrays. So this is going to have context, first and count. This returns nothing. Wait, this one is actually doing an exception instead of the GL error. That's okay. Bum, 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 bum. What is finish? Blocks execution until all previously called commands are finished. Never used this. I want to what I want to do, draw arrays. I wanted to look at the use program. Yeah, right. Just to remember. Is this not sorted? No, it is. Use to program. This just returns nothing. Okay, yeah. Okay. Main. So we will need to do something like context use program, and then we will need to do context draw arrays 0, 3, right? Because we will draw a triangle. Triangle will have 3 vertices. That's all that we want for now. So the question is, how do we put these vertices in? We need to create buffer. Create buffer. This creates the WebGL buffer storing data such as vertices or colors. So we will have another thing which is called buffer. Create buffer. Create buffer can wait. Create buffer always returns the WebGL buffer. It cannot return null. Okay, good. So this just nothing into buffer. Well, I mean, it has the context, and then it returns the buffer. Context create buffer. After we create the buffer, I need to put the data into the buffer. That function is called buffer. We have buffer data, buffer sub data. So buffers are basically just arrays with data. That's all that they are. So we can update them. We can set their value fully, or we can set the sub array. And that's all. So let's just do the full thing. So buffer data is going to be context buffer. Oh wait, we don't have the buffer because we don't have the buffer in the thing. We need the target here. Target GL enum. What type of data? Just the raw data, basically, the bytes. This is the raw API. it's just memory in the GPU. So this is just uploading some data to the GPU, and it is supposed to be typed in your shaders, basically, I guess. So over here we have a position, which is a vec2, which is 2 floating point numbers. So we should have our buffer filled with 2D vectors, which is just 2 floats. We have 2 versions: buffer, target size usage, buffer source data usage. So size, this is just allocating the buffer, and this is actually giving me the data. I want the other one. So we want target, source data, and usage. In general, array buffers in JavaScript are magic. Yeah. So this source data actually that we give it can be either so this is a JavaScript array buffer, or a shared array buffer, or a data view, or a typed array. Any of these is what we can give it. Is typed array different from an array buffer? Typed array is backed by the array buffer anyway, right? I can have the any type here for now. And usage is another GL enum. This thing returns nothing. Okay. So the only question that remains basically is how do we create this data? Also, we need to use buffer, right? Use buffer. Or bind buffer. Bind buffer, bind buffer. Target buffer. All content in JavaScript is always UTF by design, which is variable length. Not all data in JavaScript is UTF. All strings is UTF. I guess UTF-16 is what JavaScript is using. But it's not all data. JavaScript has other things than strings. I'm pretty sure, right? Okay, so we need to create a buffer. Context create a buffer, and we say context bind buffer. So the target is we have these things. We have array buffers and we have element array buffer. But what we want is the array buffer here. And then we want to give it the data. So context GL buffer data. Array buffer should have the things. UTF-32 has no other things than strings. It's complicated because of type conversion. When you write a number, it can be a lot of things. Well, it is it is not a lot of things. It can be coerced into a lot of things, but it is a floating point number. When you have a number, it's a floating point number. In JavaScript internally. So buffer data int. Yeah, this is the array buffer. This and usage. So usage in the buffer data. Usage can be this: static draw, dynamic draw, and stream draw. This basically puts it into the different memory regions of the GPU, as far as I understand it. So if you don't plan to update your data often, then you do the static draw. And then the actual data here. The actual data. Let's for now just say that it's going to be native, you know, native array. It must be expression, not place expression. This should work, by the way. I guess it works if I put it in parentheses. Okay, let's just... So I want to create this array with, let's say, so I want -1, -1. Oh, wait a second. It should not be... No, it should not be a list, right? We want an array buffer. We want an array buffer. Typed array. We want specifically a float 32 array here. Can I construct it using a list? Or is the constructor... Yeah, we have a constructor, and this has an object. Oh, you can give it an iterable also, which is doing the yielding. I never used yields in JavaScript. Buffer 44. Can I just give it a list? New float 32 array 1, 2, 3, right? No, I can. Yeah, for sure I can. So we want to just do new float 32 array. -1, -1. Let's say 1, -1, and 0, 1. Okay. Let's see if this actually is going to work or not. Wait, it actually failed. We have an error. Oh no, where the error is. Shit. If I comment this, that works. Okay. Create buffer. Oh, yes, this needs to be like that. Do I want like this also to work? Probably. It needs like some changes. Okay, this doesn't work. This one, buffer data, context, target. Oh, I see. But why though? So like it put the other things into a nested tuple. What about WebGPU? I don't know WebGPU is the issue. Or I never worked with it. So it would take a lot longer time to draw a triangle on the screen with the WebGPU is the problem. Also, it's not supported on all the devices yet, I think. Right? The question is how much do we care, of course. I'm using old WebGL still here. That's what I'm used to. This is WebGL 1, not even WebGL 2. What I'm trying to do here. So it did a different desugaring. If I do context here like this, it is actually successfully compiles, but this does not compile. Why? This is being... Why is this being done differently than this thing, for example? What if I do this all on a single line? Does that make a difference? It does make a difference. Oh, is it the trailing comma? It is the trailing comma that makes a difference. What? I guess kind of makes sense a little bit. In my implementation. So the problem is that my syntax desugaring for the pipe is just doing this first and then args, right? So it's not like should it even work like it does right now? So the args, if this is something that's separated by commas, then I could like collect all of them. Or should this always be treated as its own like thing? Let's see if I have, but the problem is in the core syntax. I can fix with the trailing comma so that it works. I have the comma impl here, right? So the way we're doing this is I'm just collecting the list. I'm collecting the list. Binary rule name is core comma. We'll collect the list, but this has also a trailing or leading rule name, and I'm not giving it here. And why am I not giving it? Comma impl. Because comma impl is used for like the trailing comma impl. Like where is the trailing comma used? Oh, because trailing comma is just giving the child, and then it like does that. Yeah. The problem is that the comma is left associative in the parser. So when I say like A, B, C, and then trailing comma, then the trailing comma like is the last thing to parse, like that, basically. But we are giving it the syntax node like this, without the parentheses though, but with these priorities, because that's how I'm constructing my AST. And this cannot be like flattened, but I can make it be flattened still, I guess. Let's ignore this for now though, because this compiles. Go here. Draw arrays takes at least 3 arguments are provided and the 2 are passed. What? Draw arrays. Draw arrays, first count. 3 arguments. Did I not just look at the documentation of the draw arrays? Oh, it's mode first count, right? We need mode. And mode is an enum. Back from exam, did everything with 20 minutes left to spare. Nice. Nice. Welcome back. Draw arrays. So now draw arrays. Here, I need to give it the mode. So the mode is triangles. We are drawing triangles. WebGL warning, buffer data. Buffer for target is null. Buffer for target is null. A buffer for target is null. Draw arrays instance. Drawing without vertex attrib 0 array enabled. Oh yeah, that's right. We need to also have all of the vertex attributes, because we have like multiple different vertex buffers potentially, and each can store like different datas for the vertexes, right? This is just the positions. Hold on. Enable vertex attribute array, right? Is there a separate vertex attrib function? Vertex attribute. So we need to enable it, and then we also need to like configure it. Where is the data coming from? So over here, specify constant values for the generic, constant values for generic vertex attributes. Index, position of the vertex attribute to be modified, the floating point number, value, vector, pointing to the things. Wait, is this, that's weird. While vertex attributes are usually used to specify values which are different for each vertex, you can be useful to specify a constant. No, we don't want the constant. Vertex attribute pointer, this is what we want. So this binds the buffer currently bound to the array buffer to a generic vertex attribute of the current vertex buffer object, and specifies current vertex buffer object and specifies its layout. Index. The index of the vertex attribute to be modified. Size, number of the components. Type, the data type. So this is where we are like typing our raw data. Stride and offset. By the way, and this also says the vertex array object. Going to create the vertex array object. First. Create shader, program, buffer. There is no such thing as vertex array objects. Oh, vertex buffer object. Yeah, no, vertex array objects. Maybe that's what we do on the native backend. Vertex attribute pointer. We need index. Size. Type. Normalized. Stride. And offset. Let's assume we want to render some 3D geometry, and for that we will need to supply our vertices to the vertex shader. Each vertex has a few attributes like position, normal vector, or texture coordinates that are defined in the array buffer and will be supplied to the vertex buffer object. First, we need to bind the WebGL buffer we want to use to array buffer. Then, with this method, we specify in what order the attributes are stored and what data type they're in. In addition, we need to include the stride, which is the total byte length of all attributes for one vertex. Also, we have to enable this to tell WebGL that this attribute should be filled with data from our array buffer. Easy, right? This doesn't work. Is it the @ symbol? Oh, it is. I cannot do that. Let's call this tie. Fine. Over here it can be type. It doesn't really matter though. So we will need to do this, and we will need to enable vertex attrib array. That's just the index, I think. index. I potentially will want to disable it later too, right? Maybe, I don't know. Disable. Let's have a disable too. So we bind buffer, we upload the data, and then we want enable vertex trib array 0 context GL vertex trib array pointer. So this is the interesting thing, right? For the index 0, for the index 0, size, right? So this is, so the we are trying to do the attribute, which is a position. In my shader, the position is vec2. So we are going to say here that the size is 2, and the type, is a float, because it's a 2D float array, a 2D float vector here. So this is GL float. Then there is normalized. Normalized is false. Wait, we don't have false, right? This is just false, I guess. Stride is the size of the vertex in bytes, which is supposed to be 2 times size of float, which is 4, right? And then the offset is the offset from the beginning of the array is going to be 0, since this is the only one right now. This is a little bit weird, I guess. But this is supposed to work. Maybe. Let's try. Well, it says buffer for target is null. Buffer data. Yeah, when I'm doing the buffer data, buffer for target is null. Buffer data. Buffer is not uploaded because bind buffer was not... Oh, because bind buffer is like create buffer here. Shit. Bind buffer. Oh, there you go. Look at this. Triangle is on the screen. Easy. Easy. First try. First try. All right. Now we need to like make this a little bit more structured. A little bit more structured. So like specifically, what is this? What are these random numbers, right? So the way we do this is we can query our program, our shader program. What are its attributes, right? So we know that basically we want to get this information that a position is a vec2, right? And then based on that, we can do some decisions on how to bind the things and all of this. We're doing some hugely based programming today. Hello, sturdy pose. We have a triangle on the screen with WebGL and Kast now. Yeah. So I want to do this like, I don't like working with raw OpenGL because this is very error prone. So instead, we want to do the querying of the shaders. So there is a thing called get program parameter. We already have it, but we get the booleans there. So we can query the programs for all of the different information. For example, the active attributes. This is what we want. So this is the number of active attributes to a program. So what are the vertex attributes that actually matter for this? And then after, so this is the number, and then we can also get the active. We can also get active attribute. So this, given the program an index, it can give us the information about the type. So like basically it gives us the information about the compiled shader. All right, what is this? I don't get the meme. Supposed to be a reference to something, maybe? I don't know. So yeah, we get program parameter, but the other one, which is an integer instead. Get program parameter int, I guess. It's still the same thing. Let's close all of the useless tabs. Right. GL int. We just have another overload which returns the int here. GL int. Next time I'll send something engine related. All right. So yeah, we do something like this. Context GL get program parameter. So we have a program and parameter is GL active attributes. Int, right? So this is active attributes. Right, so this thing is called attribute, and we want to get it. Then we just go for index in 0 to active attributes. We want to query this thing, so we want to do get active attribute thing. So this is a WebGL active info object. Active info is context get active attribute program index. Get active attribute. Context. Index. Wait, this is GL uint, but over here, oh yeah, this also was uint. Okay, yeah, sure. Active info. Program. Context. Program index. Get active attrib. Program index. Okay, so the question is, what is the active info? I don't think this should be the... well, this could be the opaque type, so that you can query what it is. Or we can just pretend that we know about it. This can break if I change my JavaScript representation. But I'm already kind of like depending on my JavaScript representation by doing this here. So yeah, we just say that this has fields, right? WebGL active info is an object which has fields name, size, and type. Name, size, and type. Name, size, and type. This is not named. Not typed here, or what? What is the type of it? Name is supposed to be a string in this case, I'm pretty sure, right? Why is this not specify the type? Anyway, I feel like type is GL enum. I think that size is GL size. And maybe, and name is a string, probably. I cannot do the type. Type is a keyword. So I want this to be the raw identifier, but raw identifier is not parsed. I think I will fix that. Lexer fixes. Let's fix the Lexer a little bit. So this is the syntax for the raw identifier, but it thinks that this over here is a single token, but it should stop reading the dot if it encounters the at. Right. So when I see a read punctuation, we have specific symbols which are single thing. So I just do say that at is a single thing. That's I think that's all that I need to do. Let's do cast. Let's do this like echo a dot type cast parse, right? So this is yeah, there we go. So this is now parsed successfully, but it was not parsed successfully previously. At is single punct whatever. I just say that. Which also means that whenever I said tie instead of type, this also can be actually called type now. Like this. It's supposed to work. As soon as this is updated. Okay. That works. So active info. This is active info. Okay, so we want to go. This is my active info. Let's just you know what? Let's just bam 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 bam. DBG print active info. We're supposed to have only one, which is the position. Not inferred variable. Something is not inferred, by the way. It seems like in my code. So yeah, we have here it is, right? We have the attribute position. Size is 1 and type is 35664. Yeah, I remember that is a little bit weird because this type is going to be not float, and this is not going to be 2, even although it is a 2-dimensional vector. The size is 1, but the this thing is going to be Is this not specified, like, what can this be? Because I think this is something like vec2. There we go. Yeah, the uniform types. We have the same for the attribute types, right? So we are going to have float vec2. I'm pretty sure. Which is different than size 2 and type float. And we will need to... I'm pretty sure that if I say over here 1 and over here if I say float vec2, like, this is actually not correct in the vector text attribute pointer. Yeah, this doesn't work because this is bad type. So over here I need to specify that this is 2 floats, but the information that I am given is that I have a single vec2, which is wrong. So we need to go for every attribute. We're going to do the attribute pointer, right? So this is our actual index I, and this over here is our index I. And where the data is coming from depends now. So this over here is the size of, like, this is stride, and this is offset. I will say that stride is 2 times 4. Because we have 2 float 32s. So 2 times 4 bytes. Offset is 0. That is different for every attribute. Stride is the same if we store everything in a single array, at least. This over here is the types that we actually need to make sure that these matches the information that I'm given here. Right, so this is going to be size and type. So I'm going to a match, but I cannot match with constants yet. So we're going to say that let size and type to be something like this. If active info dot type is equal to GL vec2 float, right? Then the size is 2 and the type is float. Otherwise, we are going to like panic. Unknown active info type. Sure. dbg print active info before that. Yeah, we're going to do this. Is it not vec2 float again? Or is it float vec2? Yeah, there it is. So the size that we get here, this is not one, only if this is an array, as far as I remember. So we're going to say that if active info size is not equal to 1, then I'm going to panic for now. Active info size is not 1. And then we also have the name, right? So based on the name, we can actually figure out the offset in our data if we have like multiple things here, right? So we are going to say that, like I want to construct my data with a different, in a different way, I guess, right? I want my data. I can also put all of the data into the different buffers, I think. Right? Can I? I think I can. When I was doing WebGL though, I was always putting all of the data into a single buffer. But that's probably something that can be done differently. Like I want my data to be something like this. I want it to be like a map from string, which is like the name of the attribute, into the actual data, right? Or something. Well, I mean, ideally, the way we do this is we specify the vertex. We specify the vertex type as something like this, where we have a position, which is vec2. Right, where vec2 is this like new type also, right? X float 32 is what we want here. We'll for now say that float 32 is float 64 because that's the only thing that I have. Right? So I want the data to be the list of these vertices. List create, and then we like list push back data. So this is going to be a list of vertices. So I push here, x is -1, y is -1. Well, this is the position, right? Position is this. Which means maybe I don't want to have the fields here. Then we just say float 32, float 32. Well, I mean, that doesn't work. I just do this then. So we have 3 vertices, right? This one, positive 1, negative 1, and then 0 and positive 1. Like this. And we want to convert this to the float 32 array.
One singular bit.
One singular bit. Just cheered 1 singular bit. Thanks. So yeah, the question is, how do we do this? So ideally, we have some form of a derived macro here. So we want to, given this list, we want to convert it into the array buffer. Another option is to another option would be to like what is the generated code? I mean, that I want, what I want the generated code to look like. Maybe let's try to do it in a separate buffers, right? So I want to have like the field is rendering in Kast. Yeah, I had a triangle already. Hello, Raymarch. Maybe I do something like you're probably going to see why my engine is actually not very fast, Raymarch, the way I'm doing things. Maybe. So whenever I want to draw something, I do some... this is what I'm doing in my actual engine, kind of, right? I mean, so we basically have like a vec of vertices, right? Like this. So in Rust, I just specify a struct with the position like this, right? And then I want to convert this and upload this data to the GPU and bind my things. And I do this every time I do a render call, basically. Because I think in WebGL there is no way to like save this information. So we need to do it like every time, maybe. But yeah, I have a derived macro for my struct here, which is doing the vertex attribute stuff. So we want to generate code like this. We have data. We have data. I want to get the actual like vertex field value. WebGL 2 has, yeah, maybe I should like update to WebGL 2. I'm just doing it my way because that's what I'm familiar with. Maybe at this point I should update to WebGL 2 though and figure out how to do things a little bit better, right? Yeah, so I want to like and my way will work everywhere. Yeah, I don't know, like if there is somewhere where WebGL 2 is not supported still. I mean, maybe there is. So we have the like, let's call it like, I don't know, bind fields, right? A single field. So a single field, in order to bind it, we have the so we have a generic function t, right? This is a vertex. This is a vertex. So we have the data, which is a list of vertices, right? And then in order to get the actual field, right? So get the field is going to be a function from v into t. So this is the type of the field, right? This is the type of the field. So I want to do this, right? So since this is supposed to be uploaded to the thing, I don't even give it the reference here. And And we know the type. Yeah, maybe that's all that I do. So I want to construct a new float 32 array. I want to construct a new buffer there. Right, I create a new buffer for every field. Can I do that? So we're going to create a new buffer for every field. And this data should be done like differently, right? I need to first to construct like the actual data and then convert it to the array buffer, right? Or can I like or is array buffer in JavaScript something like vec in Rust already, where I can add to it? JavaScript array buffer, or I need to allocate it first. Well, I mean, yeah, I can allocate it first anyway, and then put the data in. Right. There is a resize thing though. Dun, 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 dun. So I want to figure out the list length, right? We have the list length, and based on this type, I can know the thing. So I can have a trait, you know, I can have a trait, vertex attribute. This is a trait, self, something, something. What do we do for trait? So I want to like implement vec2 as a vertex attribute, right? What do I do here? Can only type variant or tuple types. Yeah, that's right. And yeah, what do we want about the vertex attribute, right? We want to know its actual size, I guess, right? So this is the size that we're going to supply here, actually. Right? GL end. We're going to have type, which is GL enum. That's the important stuff, at the very least. So for the vec2, the normal one, we're going to say that size is equal to 2, and type is float. And then we need to a way to like for this attribute, we need a way to construct the thing, right? So construct like data, construct data, and I want it to be a function which knows the length, I guess. So this should return like JavaScript any type. Like this will depend on the actual vertex attribute, maybe. So we have the length and like element constructor, I guess, which is a function returning self. Maybe. Like basically like the iterator with the elements. Or like what do I give it? Not a function, maybe. What should the API be here? I mean, I can give it like a new list, and I can construct a new list. I mean, sure, we can just have a... Let's just, you know what? Let's just have a list of selves, right? So if I have a list of selves, then I can construct the like JavaScript equivalent of the things, which is like the float32 array somehow. Right? So for this, construct data is going to be length and data. So we're going to do native new float32 array. Like I guess I need to create the list first, right? So we say that list is native empty list, and then we do something like so. This yeah. Right now it's a little bit weird to do this, but we say list. We say for this the native, it's like it's a thing implemented in the backend. So right now I'm transpiling to JavaScript, so I can just give it raw JavaScript here. So we just go into the list and I say native list element. So in JavaScript, just do list append element, right? I think. No, it's not. Append is from Python. Shit. How do you do this in push? Push. Yes, okay. So you do push. So you do push the thing. And then we create a function like this, basically. And then we call this function immediately with list and element. So that's how we actually push there. Or X. And now this list. So this is going to be a function like actual. So we have actual list, and then we return the new float32 array with the list, and we call this function with the list being the argument. Right? That is a little bit ugly, but maybe like it can be done better, but okay. Also, like I could have a native list type, which is backed by the actual lists, then I would not have to do this, I guess. Yeah, so I want to construct the new data of just these fields, and also this field must be named, right? So field name is just a string. So we have a list of vertices, we have a name of a field, and we have the getter for the field. Then we can like bind this with OpenGL. Right? So field data is, we're just going to create a new list here. When then we're going to go for vertex in iterate data. We say that push back into the field data get vertex, I guess. So there you go, we have the field data this way. And then we say that field data is, so this is where we use this trait, right? So we say t as vertex attribute dot construct data. Why do I even need the length? If data is a list, then I don't need the length. It's just a function from a list into any. That's all that I need to do, right? Right, so we just construct the data with field data. Yep. This needs a reference. Sure. So now we have this data, field data. So we create a buffer. We create a buffer, we bind the buffer, we upload the data to the GPU. Then we are going to... So these are all of my attributes, right? I have the information, but which attribute this actually corresponds to, we are going to store the active info based on the name. So we have the name here, and we can know if this attribute is actually active in our program, right? Yeah. If this is a const function, then we must give it the program as another thing. GL program. I can get the parameters here, or I can have a wrapper over a program. Is another thing that would be nice. So we can say program is a new type where we have the raw handle. This is the GL program, but we will also store the attributes here. So this is going to be a map from a string into GL active info. This means that I need to use std collections map. That's not in the prelude. So I want this thing where I was going through the vertex attributes to be done when I actually construct a program. You know, let's have impl program. Init vertex shader. So we just have a constructor with vertex shader and fragment shader. And we just return the program. So this should... So here is my active program. Yeah, so over here we do the program, we check the link status and everything. Okay. So then we return this thing where handle is program, and then we will have the attributes here too. I don't have the attributes here, right? What's the error here? Program and attributes is not equal to handle and attributes. Wait, what? Handle and attributes is not equal to handle and attributes, but it is. What do you mean? Handle main GL program. Main GL program. This over here is just not inferred because I don't have it yet. But let map attributes is map create. All right, well, now we have the error message, which is not very nice. It could not unify these things for some reason. It looks literally the same though. So the error message makes no sense. Fine. Let's comment this out. Let's say handle is underscore, or let's say program is underscore. This is also not working. Why not? Wait. Why does this work though? Oh wait, now it says over here. Handle attributes, handle attributes. Oh, it's because it's because I have a stupid typo here. There we go. I have a typo, which is why it didn't type check, which kind of makes sense. The field is different, but I need to make my error messages better, I guess. At some point. Okay, so we have this stride, which is not known. Well, I mean, this is vertex attribute pointer, and enable is not going to be done here, actually. Right? Because this, and even this, I don't want that. Here, let's do that in the... in this place, we have the buffer data, then I will need to do something. So we need to find the active info here, based on the name. But the active infos are going to be stored like once we have linked the program, we're going to query all the attributes. So over here we have active info, and we're going to map add attributes. We're going to add active info name, active info, right? Okay. So this way we can query the active info based on the name of the attribute. And when I am binding a field, I will say, let's have a return here maybe. So like if I'm trying to bind a field which is like the attribute can be inactive if it is like not used in the shader at all, I guess, because it's going to be optimized away, and then we just don't do anything here. So let's first do active info is going to be so we're going to match program attributes into map get name, right? If it is some info, then we return the info, but if it is none, then we just don't do anything. We just return from this function immediately. I don't need commas here. And this is a fat arrow. Wait, why is program attributes not inferred? Reference doesn't have fields. Yeah, this is a reference. So I would want to dereference it, I guess. Type. I cannot go to the definition. It doesn't... the type is not inferred still for some reason. Program attributes is this thing. Map string to GL active info. Like I'm supposed to have these types. Maybe map get, map. Oh yes. I need to like pipe a reference here. Right. Now this is the active info. Okay, nice. So now I can go to this definition. Okay. So I guess like to push back to a list, we can also like say move to this like that before we get fields. Sure. So now the index here. So the index is, so this is the active info index. Active info does not store the index inside, the index of the attribute. So we need to store that too. So active info that we're storing inside of a program should be a different active info. Active info is a thing which has like raw GL in active info, and we also have the index, which is an integer, I guess. So we say that over here I'm going to add the thing, right? So active info is raw is active info, and index is I. We're just going to equal. Can I rename this to index? Name is not there. Yeah, because now we have like raw name, I guess. Okay. So active info. So this is raw type, right? But the index here is active info.index. Now the stride dot index. This should be dereferenced. Enable vertex at trigger array, active info dot index. How does enable vertex at trigger array work actually? Does it enable it on the currently used program? Or is it like a global state of the OpenGL? Oh, there's also a get attribute location, so you can get it by name instead of doing that, what I'm doing. But that means the OpenGL call at the time, so I want to like store it. So we don't do that. Actually, I don't know this. Is GL vertex at like in a GL enable vertex attrib global or per program? Neither. This is per vertex array object state, not global. Okay. But WebGL doesn't have VIOs, right? Yes, it does. WebGL just pretends that it doesn't. Okay. So this we modify the implicit vertex array object. There's a single implicit hidden vertex array object which is like global in WebGL 1. So they're like global-ish. Okay. Yeah, that's why I'm enabling it every time I draw and disabling it afterwards, after I do the draw call. Let's create the data over here, like in the end. Like, because all of that on the top is the library stuff, I guess. So I want to bind field. So yeah, what we want is we want to bind field, bind field. Bind field. This means that we need to give it a program and to give it the data. I need to give it the name of the field, which is a pos, and I need to give it the the getter, right? So like data, like vertex into vertex a pos, basically. But this should be like generated for all of my fields. I cannot find program in scope. Let's move this closer to the bottom too. I mean, I should just move the certain things into the library. Let's create a new library, right? So this wrapper around OpenGL, which does all of these things, I call it ugly, because it's yes. So I just say that this is include. I guess we just go to the lib. Let's move all of this stuff here. So like compile shader, for example, goes there. What just happened? Compile shader. I mean, this still needs the context, right? Hello, Roboboto. So these active info and programs and vec2, vec attribute, all of this goes into the library. Yeah, but this means that in order to initialize a program, I need a context after all, right? Okay. Bind field also goes there. So this is going to be like, right, like context, compile shader. Vec2. So vec2 could be like common stuff. Can I just like include common here or something? Maybe we will move this somewhere else later. So bind field also needs the context here. We can store the reference to the context inside of a program, though. That's what I usually do. Also, so we have like context here, which is GL context. Right, and I give it the context here, which means that we just over here say context is program.context. Okay, so now we have the active info. Why doing the size and the type? Because this actually is the yeah, we like have this already. T as vertex attribute, right? So this is going to be size is just going to be T as vertex attribute dot size, and this is T as vertex attribute dot type. Offset is going to be 0. So the only thing that we don't know is just yeah, over here this is just should be like asserted that our stuff is correct. So we can actually ignore this thing here. Stride. So what is the stride? Stride is just the size of one vertex in this specific buffer. Right? Yeah. So we know the size, the type. So I know like the size of this type, and I know the size, and I should just need to multiply them. Yeah. So this is just going to be this times this. So this must be like a sized type. Dot size. This is my stride. So we have something like sized type. Or just has the size like this. So we are going to implement float 32 as sized type, as where size is 4. Since this is just an alias, it's not exactly correct to do this. Let's have this implementation local to like over here. Oh, and this can actually not be done right now because like right now this it wants to know this at compilation time. But that is not there. Wait, but why does it want to know this at compilation time? To figure out the type of it. So I don't do this actually? Okay, fine. I want then just this dot type size. Fine. We just say type size here. A little bit easier. Vertex attribute. So we have type, and we will have type size, right? So type size is well, I mean, we can also have like the total size calculate here immediately, so we don't multiply this at runtime. But that's okay. So this is going to be this. I need to create the program, right? So this is where we create the shaders, right? And we say that program is, so we create the shaders, and then we say we initialize this. Okay, so now I have a program. Reference doesn't have fields. Yes, we need dereference here. Go to sports. See you later. See you, Penguin. There are some type issues in this program currently. Can I move this a specific terminal to like its own thing? Move terminal into new window. Not exactly what I wanted. Okay, we have inference error over here. This. Let's open like a new full thing, just watch. Right, so I am compiling this pipe over here. Context, vertex attribute pointer. This does not type check. Oh, it's the same thing, because this over here is a comma and this is not working yet. The trailing comma in this place when I'm doing the pipe. Unless we just do this and put the context here as the first argument manually, then it should work. Okay, then this over here is probably the same. Yeah. This is the same. I cannot... context program is not context program. Really? GL use program. Oh yes, because this is a different program. The type error is bad though. Because after the error happened, the inference changed the type or something. I guess we just do instead like ugly program use, you know? I was just going to do this. Program use. Hello? What's the problem? Oh, because this is a keyword. Okay. What do I call it usually then? Let's see here. Use. Maybe I rename it to something else. Program. So this is just going to say program handle into like, yeah, we say program context into GL use program program handle like that. Okay, what else? Oh, it's compiled now. No recursive imports. For some reason, this is a weird error that I have happening. Okay, let's see if it works. It doesn't. Check to do. Get cast impl. Check to do. Transpiler line 209. Okay, we have something in the JavaScript transpiler that is not done. Line 209. T tuple. Transpile type shape. Because this is a tuple. Yes, hold on. Because I'm trying to use like a trait here. Bum, 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 bum. Gonna do it without that, without changing my transpiler. So the thing that is not compiling is basically is basically this cast. So this is happening at runtime kind of right now. And type is the and type is the type. Bum, 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 bum. Primitive, cast types primitive. I mean, this is what I'm one of the things that I can do is I can generate a new type here instead. Right? Let's see my runtime. Yeah, we just have a new type, right? This is what I can. I can have a new type. For now, this should work good enough. To do type. So when I have types to do, I return just this. Yeah. So the problem that this T is so we still have some type information to available to us at runtime. The type of the vertex attribute for me right now is the vec2, right over here. It's a vec2, and vec2 is like a complex type. Also, I cannot go to the definition. Also, which should work, but it doesn't. So there's like a tuple. And yeah. Hello tool at Turalis. So we basically like we at the runtime we keep the type IDs so that we can query for the current trait implementations. But right now for my tuples I have a to do. What I can do temporarily is I can change this into creating a new type instead, but that's not how it's supposed to work eventually. Or I actually implement it for the tuples properly. Like, what is supposed to do here? Well, I mean, this is a compound type. One of the things, though, is that this specific type is named, actually. Yes, it is named. It's not an anonymous tuple. It's a named tuple. So we can, for the names, I can actually have IDs, right? Yeah, for names, I can actually have IDs. And then I will just have the ID there, and that's all that is needed. Wouldn't work for the generic types, though. But if type doesn't contain generics, then it should work. Actually, yes. Okay. I know what we can do. So let's do a simple test example that doesn't work right now. So we have something like this. Const foo is a new type. I don't know. Let's say x is integer, right? So I want to do something where we implement some trait for it, right? Like, let's say that we implement string from string for foo, or we implement foo as string from string, and this is going to have the function parse, which has string s, and we return x is s parse. Yeah, something like this, right? So we just parse the integer there. From string. Oh, it's called from string, not parse. Right, and then let's do dbg print, so something like foo, and this is going to be, you know, like 1 2 3 parse, like that, right? Yeah, so let's do cast examples test. This is going to run through the interpreter, but in the JavaScript backend, if we do run target JS, this is not going to work because we have a to do throw new error value to do. Yeah, there you go. And we are literally pointed to this line of code where I have a tuple. Okay, nice. So I think we need to have like a name here. I will ignore the actual thing. Yeah, so we are going to match name name var inference var weight inferred. Why does your type system allow multiple implementation of a generic trait? Does your type system allow multiple implementation of a generic trait as long as the type args are different? Well, it's supposed to. There is a lot of work to do yet. Right now, I only can do implementations for concrete types, and there is no generic implementations at all, which is a huge limitation, but we'll get to it eventually. There's a lot of to-dos in the language right now, but it is supposed to work just like in Rust, I guess. It's the difference between Rust and my language is that I probably will actually want to have the local implementations. I actually have this page open right now. Look at this: stable and coherent implicits. So you have like Rust traits, and there is a problem which a lot of people are complaining about. Like in Rust, you have the orphan rules, right? And in general, you have like this basically global map of your trait implementations for all your types. What if sometimes you want to have like a local trait implementation for a type and use it instead of like whatever is actually implemented globally? So we want some way of doing that. So it can be done through the system of implicits. I don't know if they have Scala's implicits here also. So as far as I understand, you can already do this with Scala implicit. So I have opened this. I did not read this, but I thought that Scala implicit just allowed for that already. But I have not really used Scala, so I don't know much. Anyway, we do optional name, and you will need to like await inferred here. So if it is if we have no name, then we will actually do a to do. Await inferred. I need to give it to the arrow shape. Arrow shape is going to be none, I guess. Okay, so over here, if we have some name, then we do something. So name is a name. Name can contain instantiation. So if this is a generic type, but if it is not a generic type, then we will just have the simple stuff. And in this case, we can just give it the ID. Right? Yeah. Yeah, that would make sense. So I need to like check if this contains any... Let's have a name ID name. Let's do like match. Let's do like try name ID with invalid argument. Then we're going to still have a to do type because I don't want my I still want my thing to compile and not compile. So we have a name ID. This is going to be name into ID. Well, I mean, hold on. Like name. Let's do name as string. Name as string. So we are going to just create a new type. I don't know. Type. Let's have type named name. How about that? Type named name. This should return the no effect expression, I guess. So there's going to be function name into. So I need to like first check no check simple name. Name. So we are going to match name with name destruct. No, wait, name. No, this is going to be name shape, right? Come on. Name shape. Destruct. Okay, there we go. We have a simple. Then it's going to be true. Concat A and B. Let's do simple part. Check simple part. Concat check simple name A and check simple part B. And instantiation is going to return false. check simple part is name part. I guess in all of these cases we just return true. Okay, so we basically say that if check simple name, then we do something. Otherwise, I'm going to raise invalid argument. Only simple names, please. Right, so over here, I'm just going to create a name. Right, so I'm going to make string name print name shape name. So this is my actually name as a string, and we're going to calculate the JavaScript expression. We're going to call the function, which is just going to, so the function is just going to be raw. I mean, let's just do raw here. I'm just lazy here. Let's do raw. And over here. So this is my expression. I'm going to say cast types find by name. I mean, this is name first, right? But then expression is another make string cast types find by name. I mean, I don't know, like create, like, or find. What do you call this function? Like, it should create the ID if it's not existed, or like something. Create or find name, like this. And we just create the raw expression here. There we go. Okay, so now in my runtime, my types, we're going to have a function that is called create or find, where we have the name string. So this is going to say const named types named types is this, and then over here this is my like type is this, and I say like named types name is type whenever I create a name. Can I have this type, which is indexed by string, is type? Is that how you type? How do you type this thing? Where if you this is TypeScript, right? If I index maybe name string like this, that's how you do it. Yeah, okay. So we will have the named types. So create or find is going to say that if named types name is undefined, then I'm going to return new type name. So this is like existing. Is this? Otherwise, we just return existing. Such intuitive hash map syntax. I mean, it's okay. just forget it because I don't do TypeScript very often. I do it very rarely. Okay, so I'm assuming now that I try to run this through the JavaScript, then it's actually going to work. Okay, it did work, right? So we did parse this complex type, and we used this implementation. So this will not work if this was a generic type T and this was T. So I don't support the generic types. Even if we can implement foo int32 as string here. Then this is still not going to work, right? Yes. So this is now this. Because we have invalid argument. Yes. Makes sense. But this is good enough for me for now, right? Okay. Okay. We can do the same for the named variants, by the way, at the same time. You know, we have the variant types, like this. So I can have a variant, like variant 1, which contains the T inside. So we are going to do the same, but instead of returning this, we're going to return a variant 1 as sparse, right? So this is going to be foo. If I run this through the interpreter, it's not working. Beautiful. Could not find T in scope. Yeah, okay. Well, this is int32. Okay, so this works through the interpreter, and through the JavaScript it doesn't, because this over here is very similar to the tuple. This also has a name, which is also optional. And I'm going to do the same. Do I just copy paste this? It's going to be like different later. For now, we copy paste. Yeah, so there we go. So that's how we represent this in JavaScript. We have symbols for our variants and the associated data. Yep. Okay, nice, good. Support type representations for simple named types in JavaScript. Okay. Now we can go back here. And it's supposed to work. Maybe. We will try like a more complex shader then. And maybe not a triangle, I don't know. I know what we're doing right now. Making simple wrapper for the OpenGL. Okay, so this is compiled. Let's go here. All right, it says draw arrays instance. The vertex fetch requires 3, but attributes only supply 1. What does it mean? Vertex fetch requires 3, but attributes only supply 1. I only have a single vertex in my attribute. What? Stride. Offset is 0. Stride. Oh, because type size. Wait, what is my type size? For this, it's 4, right? So we are supposed to have the stride of. We're supposed to have the stride of 8 here. dbg print field data. Let's see what is the data that I'm actually like pushing to the it's none none none. Oh, nice. I think that's not correct. None none none. Okay, so we have the error earlier. What about like the field data itself? Field data itself, that's a list. Sure. GPG print. Or let's, you know what? This over here. Field. Field is this. That's dbg print. Field. Yeah, so we have like 3 things. Object 0 minus 1, this, that. Yeah. Okay. So these are my 3 vertices. That is correct. So construct data is the not correct thing, right? Because we have a list. Well, this is a vec2, right? So yeah, this is actually right because I'm creating a float32 array, but this does contain float32s because over here we have a vec2, right? And I need to push so this is like a vec, right? And I push the vec. So I need to push vec x and I need to push vec y. I guess. Okay, I don't see any errors, but I also don't see anything on the screen. Draw arrays. Use program. Should I use the program before I bind the field, actually? Potentially. No. Bind failed. Field data. Once again, what is my field data? Like, this is going to be correct now, right? Oh, wait, it still is a lot of nuns. Wait, why is it a lot of nuns? That makes no sense. That makes no sense. More none is more correct. Oh, wait, it's not X and Y. It's like, it's the unnamed tuple. Oh my god. That's why. I should not do this in JavaScript if I can. Let's just have, so like, let's just have the JavaScript list. How about that? Let's go to JavaScript and have the JavaScript list. So this is going to be opaque type. We're going to implement list like this so that we can work with lists properly. So we have init is a function that returns list, which this is going to be just native that. Right, and then we want to have a push, which is having the list. List and element, which can be anything, I guess. Sure. So we don't return anything, and we just say native list x into list push x. List x. Print value and return it without you having to extract it into a variable. Yeah, there's like in Rust there is the dbg macro which does exactly this. You can add such a function easily. Yeah, we just have a list and we push. Sure. So we say that list is JavaScript list init, right? And then we go for here. So I need to say, so this is x and y. Actually, we can destruct this. And by the way, this is a reference also. Is it not? It is a reference. There you go. So I want to say list JavaScript list push x, and I want to push y there, right? And then just give the list here. Float is not any. That's right. So like, because these lists are working with any, I can make this take like a generic parameter, so we can like not use any, but we can actually push anything there, like this. That is okay, I suppose. Okay, this is maybe working. Oh, look at this. We have a triangle now. Nice. We are back to a triangle. Okay, but now that we have this like simple wrapper, we can try to draw something more complex than a triangle. Maybe. Right. Let's say that I'm yeah, we still don't do the textures, but we can have vertices having the colors. How about this? We have colors, which is going to be a vec4s. So similar to vec2, I want to have a vec4. So it's like 4 floats. So let's say that color of the first vertex is red, 1001. The second vertex is green. And the third vertex is blue. Okay, I'm also not checking that my traits are implemented yet. We're going to instead crash at runtime, but we need to implement vec4 as vertex attribute too. So this is 4 floats, type size is still 4. Construct, this is going to be just x, y, z, and w now, I guess. Right? And then in the main, we do something like we bind another thing, which is a color, and this gives me the color. Alright. And then in our... So this is still supposed to be the same. We have an error. No, this is a fake error. So this is still the same old vertex shader. But now we have another attribute, vec for a color. And I can give, we can actually do v color here. V color is a color. So we're going to have it interpolated in between the fragments, I guess, is what you call it. And over here we have varying vec for color, and this is going to be the color of the pixel. So we can control the colors like this, right? Red, green. This is not blue. This is white. Why is it white? Am I stupid? Oh, it's 0 because it's transparent. Because the canvas is transparent, and behind the canvas we actually see the white background. I probably want to disable the transparency for my OpenGL though, right? Because otherwise it's weird. But if this is not transparent, then we're going to see the blue there. All right, nice. So, and like this code over here is supposed to be generated through the drive macros or something. Okay. All right. What do we want to draw? Is there an easy way to draw something? So like we can give a bunch of vertices and then like draw them. There's also one of the other important things is the uniforms, right? I don't do uniforms and I don't do textures. And if I do both of those, then this is going to be enough to actually be making games. And also, like, I guess the input, because we only draw right now. But that should be also not that difficult. Can I generate something? Or can we like load... Wait, hold on. How about we actually load a simple model? Hold on. We have it. We have it. Let's do a 3D model. Why do we do 2D? Let's do 3D instead. If I have GLTF, but I don't want to parse GLTF right now. Do I have an object? Can we like download teapot obj somewhere? Like this is surely the free thing to use, right? This is from the courses. Well, I mean, teapot is the free model. Let's do here teapot obj. Okay, so we want to find all the... Wait. Shit. We need to, like, parse now, right? And we need to have faces. And also, this means that we need to draw with indices. Okay. Fine. It shouldn't be that difficult to parse this file, right? We already did the OpenGL. The advent of code. Let's do obj. Parse. So we just have the string. This is going to give me the vertices, right? So vertex is going to be... We are going to have a position. Well, this is a vec3 now, so we need to have another vec. Okay, but these three vectors are all that is needed for all of the game development. Okay, so we are going to create. Well, we have vertices. This is going to be a list of faces, right? Where face is we can have like indices into the three vertices, right? Or we can have just the vertices inlined, because otherwise I would need the draw elements. I kind of want to end already, so let's try to make this quick. We just have three vertices. As string lines, for line in this. What do I have in string? Do I have starts with? Do I have starts with trim matches? Contains, find match, strip prefix. Strip prefix is not a thing, but we can do. Fine, let's do strip prefix here directly. Const strip prefix s string prefix string that should return option string, right? Okay, if prefix length is more than string length, then we return none. Otherwise, if string substring zero string length of a prefix, if this is equal to prefix, then we're going to return some substring string length prefix string length s minus string length prefix, else none. It could be written better, maybe. Whatever. So we now say that if line strip strip prefix v is some so then now we need to like split it string as string split once, let a x y z be this, let y and z be s b y z string split once. Is my language server broken? Restart. Well, it's not compiling. Oh, split once over space, of course. So it works, but my LSP still doesn't work. Maybe I need to reload. Like, for some reason, it stops doing the syntax highlighting and everything. Yeah, so I need to like create the vertices. Vertices, list create. So we're going to say vertices, list push back. The vertex. How's the error? Couldn't find a pause in scope. Equal. All right, so now we have this, and then we say that if line strip prefix f. Okay, so when we have the f's, we have the vertex positions, normals. There's no texture coordinates, so these are the faces. Okay. Strip prefix. We need to do something similar to this, but it's going to be A, B, C, I guess. B and C, B, C, whatever. Like the three vertices, right? And then we go and say that face is A is face is like face of A. B is face of B. C is face C. Result push back face. Okay, and then like face is to have a string and I guess I can do it here directly. Okay, so we need the face. No, this is not a face. Hold on. This is vertex, vertex, and vertex, right? So vertex, we need to say that string split once over the slash symbol. So the slash symbol, we have three parts here: the vertex index of the position, the texture coordinate, and the normal. But we only kind of care about like the V, and this is like VT and VN, which we are not going to care about for now. So this is the index. Is it zero based? I think it's zero based, right? So we just say that V is V parse, and we return the vertex, which is vertices list at V. This is my vertex, which needs to be like dereferenced in this case, right? No, hold on, list at. Let vertex. So this, I'm supposed to get the vertex, right? So the reference to the vertex is VS at V. right? Or no? No. Or maybe this doesn't work. Hold on. List at vs v. Like this over here should be an integer. What is this play by button in code? Oh, this thing, that's a pipe. So you have an argument and the function. So like a v piped into parse is the same as parse v. Wait, hold on. Face is a thing which has ABC, which is 3 vertices, right? Oh, because I do the semicolon here, it's I was doing the syntax wrong. Maybe that's all. But why is this not working though? That is weird. I mean, there's still an error over here, vec3. 64 is not equal a plus x, y, z. This is supposed to be the 3 floats, which is the vec3. So it still doesn't work when I'm compiling this. Why not? String into this. Yeah, that's correct. Wait, why? But why in the parentheses though? That makes no sense. Why is there parentheses around this? This should return vertex. A is V, B is V, C is V. Let V vertex like that. I have some weird errors. Maybe still is my pipe operator is not working correctly for some reason. If I don't do anything here though, if I don't do this, if I don't do this, then there is no problems, right? Okay, let's figure out what is the problem first. So vertex, to get the vertex, I need to parse this. Wait, but this also doesn't work already. Oh, wait, it's a vertex. It doesn't have ABCs. Right, that's right. Yeah, this is supposed to return a position. Is, you know, let's say 0, 0, 0. Oh, wait, now we have the infinite loop, I think. No! We have the infinite loop. No, actually, I do not. Okay. So this is just actually compiling successfully. Down. Hello, Gluon, Valnet. Yeah, I'm trying to fight my language here, because it's not very polished yet. And there's a lot of issues, but I'm still trying to write a program in it. So I want to parse this as an integer, and this doesn't work. Wait, what? This makes no sense. This makes no sense. Like, I feel like I'm hitting a bug. Number literally is inferred as this. But that's not right. Just because I'm uncommenting this line. V is a string, this is a string, because I was splitting the string twice. Right? The full type here is string into vertex. Okay. Parse V. Let's do this one thing at a time. So this is going to return... Oh, wait, hold on. Oh, wait, because parse is this parse. This is not the standard library parse. I understand now. Because this is object parse. I have shadowed my variable, and I'm thinking, why is this wrong now? Yeah, just the error message could be a little bit more helpful, maybe. I still want to call this parse though, right? So we just say string parse, I guess, for the explicit naming, and this over here also should be string parse. So here's my index. Then we have the this thing at v's. This is supposed to be vertex. So I'm going to dereference this thing, right? And then that is what we return. I mean, that is all that we return here. Okay, maybe I can just uncomment this and it's going to work. Okay, seems like it does. Right, and then we just push this to the result, right? Okay, so now I think I should be able to do this. Okay, so here's our main, right? Here's our main. So we are not doing the triangle anymore. We're having so this is going to be not used. We are instead going to say that const data is object parse stdfs read file std path dir name file slash teapot obg, right? I think this is supposed to work. It's running. Oh wait, now it's like actually very slow, because I'm trying to do this at compile time to parse the teapot, which is very slow. Because this is a big file, so my LSP is now lagging. If I want to do this at runtime, then I need to way to load this file at runtime. One thing that we can do is we can say like teapot source. So I'm going to read the file at the at compile time, but I'm going to parse it at runtime, like this. Right? So this is a string, so this is actually done at runtime, and this is done at compile time. Okay, so we will have just the position. Data is a list of this. Oh, these are faces. These are faces, and I want to turn it actually into... because this is a list of faces. I want to do the raw data, kind of, right? Yeah. So these are like faces. Faces. We are going to say let's move vertices still. Let's create for face in iterate faces. We say that vertices push back face A, face B, and face C, right? So we have like 3 things like this. So the amount of triangles that the amount of things that we draw here is going to be list length of the vertices, I guess. Well, and VS is my data now. Right? Okay. You think it's going to work? I think it's parsing the... oh no, it's transferring from the local host. Split once, separator not found. Oh, I'm doing the S. This is supposed to be... no, yeah, S. WG print S. WG print S. So over here, I'm parsing over everything, right? It takes a while to parse it. And then this over here to... yeah. Wait, so you have an object in the teapot, where you have a face, which actually... yeah, this doesn't have the slashes. Oh, because I was looking at a different file. This is a... yeah, okay. We don't have the slashes. Over here. So just parse this directly. Okay. This takes like 10 seconds to load it, but yeah. What exactly does take that much time? Out of bounds, by the way. Maybe it's one based here. Should this be -1? I don't know. Let's just try this -1. The problem is that I'm compiling my JavaScript. Everything is async, even although it does not have to be. In order to do the proper JavaScript, where I just do normal code, and like not every function is always async. In order to do that, I need to infer the asyncness, which is not done yet. Well, I mean, I can just toggle the switch, though, if I really wanted to. So the real question, though, is like I'm trying to draw the teapot. The teapot, we're not going to see it on the screen, right? The coordinates are from -2 to +2 or something here, right? Yeah. Okay, and then it's like putting these data together and stuff. Can I have a simple switch? I think I do have this simple switch. It's called over here async functions. That's true. I can try to do false there. Wait, hold on. I see something. You see something on this screen here, which is actually like a shape. I think this is the bottom of a teapot, is what we're seeing here. We just need to zoom out a little bit. Maybe I can like change this to false, and then try to compile it. Kast, compile target.js output. Can I like output projects Kast game example target compiled main mjs, and I'm trying to compile projects Kast game example source main, right? It's actually that slow to compile. What is it doing? Or am I having the infinite loop there? Somewhere. True comp time program. There is not much happening at comp time. I'm not parsing the teapot at comp time, right? I do it at runtime now. It's not using the CPU though, is it? No, it is. It is using the CPU. Something is wrong. But what is? What if I just do compile without target.js? Nothing is going to happen then. I think... Wait, hold on. I think I've seen that issue before. It means that my arguments are not correct. Or something. Right? Can I, like, do this? Okay. It makes sense. Compile. Okay, it is compiled, right? Compile. Target.js. It is compiled. Okay. I feel like sometimes when my arguments are not correct, I'm having an infinite loop. Maybe like my command line argument parsing is wrong. Right? Like this works. Okay. Did I write something else before? Wait, it's because the output path is this? But why would this make a difference? What? What? All right. We can do this and then copy it, I guess. Wait, what is this? Why am I seeing a lot of WebGL active infos here? Is it miscompiled now? Because we're supposed to write the other things, right? Huh? What's happening? $3D teapot. You could trim it just to see. Yeah. I mean, yeah, if we want just to see it, well, I mean, I was just going to change my vertex shader so that I can like divide my position by like 5 here, and that's supposed to already work. You know. Fine, let's just wait. Wait, but it still now says the WebGL active infos. What is this? Is the watch taking a lock on the output file or something? I'm watching a different folder. I'm watching the source folder, not the target folder. So it's supposed to work still. Did I change something in my program? In the end, main. Let's do test object maybe. Test object. Let's do this object. You know, we have 0, like we have vertex 0, 0, 0. We have vertex 1, 0, 0. We have vertex 0, 1, 0. We have vertex 0, 0, 1, and we have face. We have face 1, 2, 3. We have face 1, 3, 4, and then we have face 1, 4, 2, and we have face 2, 3, 4. Right, this is supposed to be like the tetrahedron, although we don't have the camera, so it doesn't really matter here. Okay, the problem is why am I showing the WebGL active info? Oh, maybe it's because my shader is not compiled or something. Let's see, dbg print. I'm doing dbg print on like over here, right? Active info. Can I dbg print this? To see if that's the issue. What? Everything was working and now it's not. Okay, let's start by hello world again. In main. Let's comment this out. dbg print hi. Can this work? It doesn't. Because I'm trying to compile my program, right? Let's do this before. dbg print yo. And hi. Let's do both. It's like... What is it doing? This code doesn't exist. Let's comment everything, except for the prints. It's loading the wrong file. Just build. Node, target this. This is what's supposed to be, right? So why is my browser doing this? Browser cache, but I'm doing Control-Shift-F. Control-Shift-R. And I'm doing this with open this thing. How do I clear the cache in Firefox? Like, I click reload and nothing happens. Maybe... Oh, page is slowing down. Maybe I just need to, like, go here again. Disable cache box.
Don't think too much about this.
Okay, I will not. Maybe it's because, like... Maybe it's because I was loading the thing that was actually hanging or something.
Hello, Gorley.
Maybe that's what was happening. Okay, so yeah, there we go. So like this is loaded, right? This is my my thing. If we rotate the camera, we would see like that it's not just a triangle, but actually the tetrahedron, right? But let's now open the actual teapot. Compile. Okay, let's wait for the teapot to be loaded. I'm pretty sure this should all work. It takes a while though, but it's okay. We can work on performance later of the transpiled code. It is supposed to work really quickly, right? How many lines of code is there in this thing? File source teapot. It doesn't tell me, right? It's 10,000 lines. It's not that big. Oh, Pigorli subscribed with the Prime. Hello, Pigorli. Thank you for the Prime. 34 months. So yeah, it parsed the object file, then it does like all the other things. Oh yeah, also another problem with the performance is that... I know another problem with performance is that my lists are backed by trips right now, because I don't have lists in the language yet. So I'm using the trip data structure to do everything, which adds a like pretty big overhead, I suppose. Although it should still be quick if you write it like natively. Look at this, we have a teapot. Nice. Takes like half a minute to load it, but we do have a teapot on the screen. But yeah, I think this is enough progress for today. We can do more like stuff later. All right, yeah, we're going to go somewhere else now.
What play on DX12 or Vulcan?
Just got here. Well, I've been streaming for 6 hours, so yeah, I need to go. Hi, Joseph Wisman. You arrived just at the end. But you can see this glorious teapot here, which was drawn by me transpiling into JavaScript. My language, which is cool. I don't know, let's go to cakes.
The community.
See you guys next time. Thank you for watching. Bye.
Mod instead. I could mod you too. If I need more help, I'll mod you too. Okay, Peter? You've been very nice too.